Hi, this is Mrs. Jackson, and this is a quick video on how to simplify cube roots. We know that this is a cube root because we see an index number here of 3, unlike the square roots, where we kind of drop that number. A cube root is the inverse operation of a cube. That means a power or exponent of 3. So for example, if I had 2 times 2 times 2, that would equal 2 cubed. And the inverse operation, if I want to undo that cube, I could take the cube root of 2 cubed, or 8, and I would get back the number 2. Alright, so let's start to look at just this constant here, 320, and we're going to break that down. I'm going to write it here. Now 320, the first thing I see is 32 times 10. I'm going to start to break this down into prime factorization. You might see 40 times 8 or 80 times 4. It really doesn't matter. You just want to start to break this number down. So I'm going to say it's 10 times 32. And I'm going to go all the way down to the prime numbers. You don't have to do that. You can just look for your cubes. But just for demonstration purposes, I want to break it all the way down. Alright, so if we take a look at this prime factorization tree, we've got it all down to prime numbers 2 and 5. The one thing I would caution you on is when you look at the list of numbers, make sure you grab all of them at the bottom of the tree. It's easy to miss this 2, for example. Alright, so we have 6 2's. Multiplying by 5. So we basically have cubes here. Let me rewrite them. We've got 6 2's. I'm going to write them all out. And 1 5. And here is a cube because we've got 3 numbers. And here's another cube. Okay, so we have basically the number 8 times 5 represents the number 320. And we've got our greatest perfect cubes there, 2 8's. All right, let's take a look at our variable terms. First, x to the 4th, we have x times x times x times x. And this is a perfect cube here. I'll circle it. So we have x cubed times x. I'm going to just break these out. And then finally we have y to the 5th power. That's 5 y's multiplying out. And our perfect cube would be 3 of them. So we have y cubed times y squared. Alright, so we can represent 320x to the 4th power times y to the 5th power as a product of these expressions, which help us spot these perfect cubes. All right, so let's rewrite our expression over here with our cubes. We've got 8 times 5, and we've got x cubed times x, and we've got y cubed times y squared. And I'm going to break those out. You don't have to do this every time. It'll become natural for you, but I just want to demonstrate the product of roots property. We can pull each of these perfect cubes out. So I might as well circle them just to highlight them. The 8, the x cubed, and the y cubed are all perfect cubes. So I'm pulling them all out separately. And of course, what's left are imperfect cubes, so I have to leave that 5 in there, the x, and the y squared. Alright, so go ahead and take each one of these perfect cubes. So we have this here is cube root of 8 is 2. Got another one. Cube root of x cubed, of course, is x. Cube root of y cubed is y. And what's left in the cube root here are imperfect cubes, so we have to leave them. And the last step is just kind of button up and simplify. 2 times 2 is 4. And that would be our simplified cube root. Hope this helps. Take care.